Okay, so question 1 says, find the first derivative of each of the following. So if you remember the other class that we had, I think we did the basic methods of differentiation. So derivative so that we could use them here to answer question 1. So question 1a says find the first derivative of y is equal to e for hyperbolic tan of root x. Okay, so one thing we know is that the hyperbolic tan derivative is hyperbolic sec squared. Okay, if I put x, it will be x there. So if I put hyperbolic tan of u derivative, it's going to be u prime, and then hyperbolic sec squared of u. You see that? So in this case, to differentiate e, again, if I'm differentiating eu, I get u prime eu, like that. So meaning, here we're going to have dy and dx to be equal to the derivative of this guy, which is 4, and then hyperbolic derivative of hyperbolic tan, which is equal to sec, hyperbolic sec squared, the root of x. Then we differentiate the root of x. We're going to get we're going to get derivative of root x, that's half, x power minus half, and then you multiply by e to the whole power. So you write it properly now. This 2 divides into the 4. The 4 becomes 2. And then hyperbolic sec squared of root x over root x, since x to the power negative half is the root x in the denominator there. And then e 4 hyperbolic tan of the root of x, like that. Okay. So that's a bit easy there. We go to b. b is f of x is equal to sine inverse of x power 3 plus x plus 5 power x. So again, if I have y is equal to sine inverse, I'm reminding you there of u, then my y prime is equal to u prime over the square root. The square root of the that's the square root of 1 minus u squared. So if we come back to this one, we'll be saying the derivative of this guy. Our u is going to be x3 plus x, so that u prime becomes 3x squared plus 1. So we're going to have 3x squared plus 1, and then divide by the root of 1 minus the whole x3 plus x must be squared. And then plus, if my y is equal to a to the power u, then y prime is a power u, ln u, ln a, everything multiplied by u prime. So in this case, u is 1, so it's just going to be 5x ln 5, and then x prime is 1. So this is going to be the solution for this one. So we just respect the base there. Okay. We go to C. We go to C. So C is ln x plus y equal to xy minus y power 3. So here we use implicit differentiation. So we differentiate x, I will get 1, plus we differentiate y, we get 1 multiplied by dy dx, and then divide everything by x plus y. Since whenever I differentiate ln u, I get u prime over u. And then equal to, you differentiate x, y. First you differentiate x, you get 1 times y, plus you differentiate y, you get 1 times x. Then because it's y, we multiply by dy dx. And then minus 3y squared, again, by dy dx. Then we make dy dx a subject. So we first multiply throughout by x plus y. So we're going to have 1 plus dy dx equal to y, x plus y, plus x plus y, dy dx, minus 3y squared, x plus y, dy dx. You see? So they are just multiplying throughout by x plus y. So I can even show here that I've multiplied throughout by x plus y. Then now, all the parts that are being multiplied by dy dx, we move them to the left, and then the constant one to the right. So we have dy dx minus x plus y, dy dx, plus 3y squared, x plus y, dy dx, equal to y, x plus y, minus 1. And then factor out dy dx. So we have 1 minus x plus y, plus 3y squared, x plus y, and then equal to that. Then we divide throughout by this guy, so that we remain with dy dx that we want, leaving this side. So you see, this goes, so we have dy dx equal to y, x plus y minus 1 over 1 minus x, y plus x, the same thing there, plus 3y squared, x plus y. That becomes our solution there. Okay. And then the next one, which is D, is y equal to hyperbolic cos and then sine. I'll just put sine x because it's just sine here. And then minus 1 x squared ln x. So this one is not making much sense in the way it is written. So maybe I'll write it as hyperbolic cos of sine x minus x squared ln x, like that. Then find dy dx of it. So I know that the derivative of hyperbolic cos is hyperbolic sine positive. And then we maintain the inside functions. And then get to multiply by the derivative of the inside function. So that derivative of sine is cos x minus the derivative of x squared, that is 2x in x, plus, so I'm using our product rule. So I differentiate ln x, I get 1 over x. So that it becomes hyperbolic sine x minus x squared ln x, and then cos x minus 2x ln x, and then minus x. Since the x into x squared, we get x. Like that. And then E, tan inverse x over y. No, I mean y over x. Tan inverse y over x equal to half ln x squared plus y squared. So when we differentiate a tan inverse, so if I have tan inverse of u and I want to differentiate, I'll get u prime over 1 plus u squared. So in this case, our u is y over x. So being y over x, when you differentiate it, you use quotient rule, where you let your u to be y and your v to be x. Your u prime will be dy dx, and your v prime will be 1. So you have u prime v minus v prime u. That is x dy dx, okay, minus y everything over x squared. Okay, because we are doing u prime, I mean v prime, which is 1, times u, which is y. And then this whole thing was a derivative. Okay, the derivative, which is the u prime, which we are getting, over 1 plus y over x squared equal to, we now differentiate on the right. So we get a half, and then differentiate 2x plus 2y dy dx. And then divide, since it's ln, you divide by x squared plus y squared. Like that. So now this guy can be written, interesting. You can write it as x dy dx minus y over x squared over x squared plus y squared over x squared. So equal to half 2x plus 2y dy dx over x squared plus y squared. So you see, this x squared and this one will cancel when you do the flip, and then this guy and this guy will cancel because they are all denominators. So when you cross multiply, they cancel, and so we are going to remain with with x at dy dx minus y. So we remain with. Is there a question? Oh, wonderful. So it's going to be equal to x and dy dx, and then minus y equal to. So when I multiply half by 2x, I'll get x plus y dy dx. So now I put things together. So we have x dy dx minus y dy dx is equal to x plus y. Then factor out dy dx, which is going to be equal to x plus y, and then you divide by x minus y. This will be our final solution. So where I just need to take your time is on this stage, where you should see how those things are canceling. There, cancel. After common denominator, x squared down there, you have x squared plus y squared on top over x squared. Then the x squareds cancel. Then these ones, when you cross multiply, because you have this set and that set, so again, they will cancel. Then you end up having a dy dx is equal to x plus y over x minus y. Okay. Then we go back and do, that was E. So we go to F. We go to F. F log 3 root y equal to x squared minus 1. So you first write this as ln root y over ln 3 equal to x squared minus 1. Okay, if you want, you write it further as 1 over 2 ln y over ln 3 equal to x squared minus 1. Okay, further as ln y over 2 ln 3 equal to x squared minus 1. I haven't yet differentiated. I'm just trying to make my thing nice. Okay, I can as well write it as, okay, I want only ln y on the left, and then everything else goes to the right. 2 ln 3. Then I can differentiate. So I'll get on the left, derivative of y is 1 multiplied by dy dx over the whole y equal to, I differentiate x squared, I'll get 2x. I differentiate 1, I get 0. and then multiplied by 2 in 3. So that we have dy dx. If we cross multiply the y, so it will be 2 times 2, that is 4x in 3 multiplied by y. So since we don't know what y is there, we didn't solve for y, so we just leave it like that. But if you wanted to know what y is, you could go back in this line, the line y equal to x squared minus 1, 2 in 3. Because here, if I apply e, I'll remain with y equal to e 2 x squared minus 1 in 3. You see that? So you could write it in different ways. So then if I want, I'll come back here and say, okay, so my dy dx is actually equal to 4x in 3 multiplied by e 2 x squared minus 1 in 3. Like that. Okay. So that was question 1. Now we go to question 2. That is if there are no questions there. And now again, you just joined in halfway. But keep following, because I'll still send the video where you get back and follow from the first part. But if you have any question, you can ask. Okay. We go to question 2. Question 2, we are finding the nth derivative. The nth derivatives. Part 1, y is equal to the root of 5x plus 1. Okay. The root of 5x plus 1. So we can differentiate there and get, so let's start differentiating the first one. Y prime is going to, this guy can be written as 5x plus 1 to the power half. The first derivative will be half down, 5x plus 1 to the power minus half multiplied by 5, which you can write as 5 over 2, 5x plus 1 to the power minus half. That's the first derivative. The second derivative is 5 over 2 multiplied by minus 1 over 2, 5x plus 1. Subtract the 1, becomes minus 3 over 2. And then we multiply by 5, the derivative of this guy. We can write this as 25 negative over 4, and then 5x plus 1 to the power minus 3 over 2. The third derivative, minus 25 over 4 multiplied by minus 3 over 2, and then 5x plus 1. We subtract a 1, it will be minus 5 over 2, and then multiply by 5. The derivative of this guy So it's going to be positive 125 over 8 multiplied by 3, and then 5x plus 1 to the power minus 5 over 2. Okay, so if deliberate not multiplied the 3 by 125, we go to the fourth derivative. That will be 125 over 8 by 3 minus 5 over 2, and then 5x plus 1. We subtract a 1, it's minus 7 over 2 multiplied by 5. So you see, that we have 125 by 5, which is the same thing as 5 power 4, over 8 by 2, which is again the same thing as 2 power 4. And then we have minus 15 here. And then 5x plus 1 to the power minus 7 over 2. So we could keep going. If we did y5, we'll have 5 power 4 over 2 power 4, and then minus 15 minus 7 over 2, and then by 5, and then 5x plus 1 power minus 9 over 2. You see? So this is going to be 5 power 5 over 2 power 5, and then what is 15 by 7? So 15 by 7, that's 105. That's 105. And then 5x plus 1 to the power minus 9 over 2. Like that. So the pattern keeps going. We could have y6 and so many. So if we go back to the first one, we could see that this guy is actually 5 over 2 to the power 1. And the other part, we could write it as 5 over 2 as 5 over 2 power 2. And then the third one, we could write it as 5 over 2 power 3. Then the fourth one, as we can see already, it's already 5 over 2 power 4. Power 4. And then this one is 5 over 2 power 5. Okay, so there we have no much issues. Okay, so meaning that our yn derivative is going to, now see there's this minus that keeps coming and going, minus, plus, minus, plus. So we'll attend to it, we'll say minus 1 to the power n, because whenever n is odd, the guy is also, we have a negative. That's the nth derivative. Okay, let's see. So the first one, when the first derivative is that, we're getting, so it will be n plus 1. Yeah, n plus 1. So the first one, 1 plus 1, we get 2. So that's why it's positive. The second one, 2 plus 1 is 3. That's why we have the negative. The third one, 3 plus 1 is 4. So we have the positive. Okay, so we treat that one there. Then the second one is 5 over 2 to the power n. 1, 2, 3, 4. We keep going. Now, what about this number that has just popped up? This number here. The 3 the 15, the 105. So that number, I want us to write it as not so nice though, as 2n minus 3 factorial. And then we put another another factorial. And then we describe it as, we give a description that where this guy is going to mean the product of odd numbers up to the difference 2n minus 3. Let's go to the first part and see if it will make sense. So the first part, 2n minus, so that will be, maybe we restrict any also. We say for any greater or equal to 2. So avoiding a negative, so that for the first part, don't look at it. Then for the second part, when n was equal to 2, we could say 2 by 2, that's 4. 4 minus 3 is 1. And then 1 factorial, meaning 1 by 1. There's only one odd number, so 1 by 1, you get 1. So that's why it's 1 there. And then when n is 3, we'll get, when n is 3, we'll have 2 by 3 minus 3. That will be 6 minus 3, which is equal to 3. And then count how many odd numbers are there. You have 1 and 3. So when you multiply these two, you're saying 1 by 3, it will give us a 3, which is a 3 which we have here. Okay? Then you got the second, the 15. You will say, okay, that is my n now is 4. So I'm doing 2n minus 3. That is 12 minus, I mean, that's 2n, that's 8. 8 minus 3, which is equal to 5. So when I get 5, how many odd numbers are with 5? Are they up to 5? So we have 1, 3, 5. So we multiply them. We have 1 times 3 times 5 is giving us what? 15. So you keep going. You see the next one will give us 105. Because then we're going to have, that's 5. So we have 2 by 5 minus 3. That is 10 minus 3, 7. So you multiply again 1 by 3 by 5 by 7, which is 105. So I'm going to put that here. 2n minus 3. Or even just a single factorial. No, but we'll put double just because if you do a single factorial, you'll be getting the actual factorial, which is not correct. So put a double, and so that somebody looks for the explanation of it. Okay, and then we'll have the other one, which is 5x plus 1 to the power 1 minus 2n over n. I mean, over 2. The denominator there is fixed. So you see, if you follow it, that one is easy to see the power. Yeah. So the power is easy to see. So when n is 1, you have 1 minus 2 over 2, which is negative half. When n is 2, that's 3 over. So that's how it's going to be this one. Not so nice because of that part where we have to explain something. So you need to write this statement. Okay, so you say where this is part of the answer. I mean, up to even this one. So you say where 2n minus 3 double factorial is the product of odd numbers up to 2n minus 3 for n greater or equal to 2. So you'll see that now when we go to the one that is asked for us to find, question says find y9 and y12. So y9, using the same formula, you just substitute. Where there's n, you put 9, and then compute this part. Okay, so let's do the one for 9. Let me just rub the y4 part. Let me erase this part so that we do the y9. So we find a y9. So you say, okay, I'm just substituting. So -1 power 9 plus 1, which is 10. And then 5/2 power 9. And then we now compute 2 by 9 minus 3, which is equal to 18 minus 3, which is 15. So we'll have which numbers? We'll have 1 by 3, by 5, by 7, by 9, by 11, by 13, by 15. Yeah. So all the odd numbers there. Okay. So you do, so you need to find this number and put it here. Okay. After you put it there, and then you have 5x plus 1 to the power